Today our lesson is talking about area of regular polygons. We will learn how can we find the area of regular polygons. Now, what is the regular polygon? A polygon, it is a shape with straight sides without curve, and we called it regular because all the sides have the same length. If the side is if this shape from three sides, we call it triangle. If it's from four sides, we called it quadrilateral. And we said in the previous two lessons, it could be kite, it could be rhombuses, it could be trapezoid, rectangle, and square. And also pentagon, if it's from five sides. No, from chemistry, like from organic, I think penta, it's mean five carbon, I think, or carbon 5CH, as I remember. Hexagon, it's six sides. Hexagon. Heptagon, it's from seven. Octagon, 8 sides. Nonagon, 9 sides. And decagon, 10 sides. These are the name of the polygon from its number of sides. This is the definition of the polygons. Now, as we said at the beginning, we learn how can we find the area of a polygon. Now, before we start, if you know, or as you see from here, if you have this circle here, okay, and all of us know that any circle, it has a radius and it has a center. So imagine that this is the center approximately, that's the center of the circle, and this is the radius of it. Now, if you now circumscribe a circle by a sides like this, then by like this, like this, like this, and like this, and so on. As you see, here we have these points. We call them the vertex of the shape. Now here we have 1, 2, 3, 4, 5, 6, 7, and 8. So from here, as we have, all of us know that a circle, it has a points. These points, we call them vertices. Now, if we connect between 8 vertices here, we have a shape from 8 sides. We called it an octagon. Now, sorry. So this shape, if we connect between them, we name it with an octagon. Then, as we said, so this point, we called it a vertex. This side that connects the line segment that connects from a circle, or sorry, a center of a circle to any vertex on the shape or on the circle, this side we name it with also a radius. Then, if you have a straight line, this line is perpendicular to any side of the polygon, we called it an apothem. It could be here, it could be here, it could be here. It must be perpendicular on any side. And all of the apothems have the same length, and all the radius have the same length. So from here, we know that what is the meaning of a polygon, what is the radius of the polygon, or what is the same as the radius of the circle, the meaning of the apothem, and the vertex. And also, if you know that, if you have this shape as an example, oh no, sorry, not this shape. If you have this one. And I asked you now what we called it hexagon. And this is a center of the hexagon. If we connect between its vertices, as you see from here, we make an angle. Now, this one, we name it as an angle theta. How can we find the measurement of an angle theta? To find the measurement of it, all of us know that only the summation of angles for the triangle only is 180. But for any shape that has 4 sides and more, we say that the summation of the angles is 360. Now, for the circle, it has 4 sides. So the angles in it, each of one are 90. Why? Because we have a circle and all the sides or the angles are equal. So we will say 360 divided by how many sides here for the circle? They are 4. So because of that, we will say that each angle in a square is 90. Now what about a pentagon? The pentagon is regular. What does it mean? That means all the angles and all the sides are equal. So what about the angles now? How can we find them? We will say here we have
divide by
a hexagon. How many sides for the hexagon? They are 6. So we will divide 360 by 6, which is 60. That means each side here, each angle here, the measure of it is 60. This is for the hexagon. Now come back with an octagon. For the octagon here, if I ask you now to find the measurement of this angle here, or I ask you about this angle, all of them have the same magnitude. How can we find them? We will say it says
divide by 8, which is equal to 45.
360, and I will divide 360 by 8. If you divide 360 by 8,
it's 45.
It will be 45. Thank you. So that's mean the measurement of an angles in the octagon is 45. This is the meaning of the polygon, or the definition, sorry, of the polygon. Now, finding in this problem here, we will learn how can we find the measure of the angle measure. The figure at the right is a regular pentagon. What's the meaning of pentagon? That's have mean 5 sides with radii and an angle and an apotheme drawn. What is the measure of each numbered angle? Here, as we see, we have this pentagon. This pentagon here, if you want to draw it as a big one, this is the first side. Oh my God, what's this? Okay, imagine that is a regular polygon. Now, here now, as you said, we have this point and the distance from any vertex to this point, we called it a radius. Then, angle 1, the measurement of angle.
We will make 380 divided by 5.
Your angle 1 is here. Then, if you make this one here like this, here, we make an angle 2, and this angle here is angle 3. So as you see, sorry, from here, this one is a pentagon, and this pentagon, as we said, it has an angle, a central angle. How can we find the measurement of this central angle? As we said, the measurement of any shape that has 4 sides or more, the measurement of all of them are 360. Now, since we have 5 sides, we will divide it by 5. Then 360 divided by 5
76.
will be 72.
Which is 76.
No, Miss, why? 2 times
Oh,
5.
360. Okay.
So the measurement here, it will be 72. So here, 72. Here it will be 72. And here also it will be 72. Now, look at angle 2. As you see from here, here now, if you look at this big triangle, okay, this one here, the of all this angle, it will be 72. Now, angle 2, it will be half of an angle of the central angle. Is it right?
Yes.
Here is one, all of them. Here I will repeat.
Which is 38.
Now here is angle 1. Here is angle 2. Now, all of this is 72. And all of this big one here, if you mark it with a light line, all of this one here is 72. And all of this here is 72. And all of this here is 72. If I asked you now about measurement of angle 2, you will say it is 72 divided by 2, which is 36. Now, do you know why? Why
Yes,
we say that
because
the measurement
we
of
have
angle 2?
two sides.
Why did we now? A measurement of angle 2 is half of the measurement of angle 1. Did you know why? Yes, Maya.
Because we can
Yes, Sausan. Yes, Sausan. Yes, sorry.
we can prove that the two right triangles are equal. Basically, the apothem is an angle bisector.
Yeah,
Because the
yes,
whole
exactly.
angle is
The
equal
yellow
to
line, this
72.
one, yes, the yellow line is a bisector. Why? Because it comes and it's bisect or cut the base with two equal sides. It is perpendicular on the side. So, and all the apothem are equal. So we make an isosceles triangle. And we said in chapter 4, I think, that if we have an isosceles triangle and there's a bisector that's cut the apothem into the sides into two equal sides and perpendicular on them, that's mean, I will repeat this, the postulate or the theorem here. If
Isn't
we
this the HL theorem?
no, not HL, it's
Okay.
in lesson chapter 4, isosceles and equilateral triangle. It's a theorem, yes, but it's not HL. HL, we say if we want to prove that these two triangles are congruent, if they have the same hypotenuse or congruent hypotenuse.
Yeah, but then can't we just
yes.
can't we use this and then we can say that the corresponding
yes.
parts of congruent triangles are congruent?
Yes, yeah. If we prove that these two sides are congruent, if these two perpendicular triangles are congruent, we will say that any angle or any sides and corresponding sides or angles in them are congruent. But there's another triangle says that if you have an isosceles triangle, and in this isosceles triangle we have a bisector. This bisector, it comes from the vertex angle perpendicular on the base. If it is in isosceles angle and perpendicular on the base, that's mean it cuts the base into two equal sides and it will be perpendicular on them. This won't happen. If it is happen, it makes these two angles are the same. If it cuts them into two equal sides or into equal measurements. Here we have the same. Here, oh my God. Here we will have the same. What does it mean? If you look at this triangle here, so let me change the color. If you look at this triangle here, In this triangle, as we said, all the apothegm have the same measurement. So, and this line, it's perpendicular on the base. That means it cut these two angles into two equal half. If all of the, and I mean, if this is A, B, C, and D, so the measurement of an angle ABC, which is the measurement, which equal the measurement of an angle 1, that's we find it before, it will be 72. Why? Because we divide 360, sorry, by 5. Now, I want to find measurement of angle 2. Since they are equal, so if I divide the measurement of an angle 1 by 2, we will divide the measurement, we will find the measurement of an angle 2, which is 36 degrees. Is it right?
Yes.
Is it clear?
Yes.
Yes, it is.
Okay, so the measurement of an angle 2 now is 36. So let's see, here is 36, and here it will be 36. And since it is perpendicular on it, so what is the measurement of, where's angle 3? Oh, I think here is a 3.
Yes,
Then,
I was about to ask you.
here, is 36, and here is 36. Here is, since it is a bisector, so it cuts, or it's perpendicular on the side. So if you look at this triangle here, in this triangle, or let's make them, if here is 90, if here is 36, what is the measurement of an angle 3?
We will make 36 plus 90 equal 180.
Now, we all of us know that the summation of an angles in a triangle is 180. So the measurement of an angle 3 plus 90 plus 360 is 180. So 90 minus 36 is 54, right? I think 90 minus 36 is 54. Is it right? Let's use the
Yes, it
calculator.
is 54.
So the measurement of an angle 3 is 54 degrees. This is how can we find the measurement of an angle 3. Is it clear now?
Yeah.
Now, at the right here, we have a portion of a regular octagon. Has a radii and an apothegm drawn. What is the measure of each numbered angle? Here we have an octagon. How many sides for the octagon, ya Habiba?
8.
8, thank you. So here we have I don't know how they draw them. So imagine that this is an 8 sides, okay? It is a shape with an 8 sides. Then, if you cut them like this. So now I will look at the down half. Here now, as we said, we have this vertex. So we have this. This is angle 1, and this is an angle 2.
We step into the 60.
And here we have an angle 3. And here we have an angle 3. So let's find now the measurement of an angle 1. Yes, Maya. What is the measurement of an angle 1? Yes, Maya. 360. Thank you. Divide by how many sides for the octagon?
8.
8. Thank you. Thank you so much. So it will be 45. So the measurement of an angle 1 is 45. Lemma, what is the measurement of an angle 2? Yes, Lemma. If you don't know, tell me.
Teacher.
Yes, Lemma. What is the measurement of an angle 2?
It's half.
Thank you. It's half measurement of angle what?
Of
Of angle 1.
1.
Thank you. Which is 222.5. Thank you so much, Miss. Now, so in this side, in this triangle here, if we have this right triangle, we say that this is 22.5 and this is 90. So what is the measurement of angle 3? Yes, Rose.
It is 45. Oh no, it is 22.5 plus 45 plus measurement 3.
Wait, 22.5 plus 90
Yeah, plus 90.
plus measurement of angle 3 is equal to
Equal 180.
180. So the measurement of angle 3, let's just subtract 90
It is, I
22.5.
will make it equal.
I
It is
found it.
67.4.
It is 67.5. Thank you.
Teacher,
Yes.
how did you get 22.5?
From where?
Yeah.
Okay. هلا here look at this triangle here. Up, okay, in the from the book. Here we have angle 3. Here it is 90 because we said that the bisector cut the sides of perpendicular on the base. And you saw Maya, you said that the angle of the central angle is 45. Then Lama said the angle 2, which is here, is half of 45, which is 22.5. Then here we have we have a triangle with 3 sides. 2 sides are known. What about the measurement of the third angle? Sorry, 2 angles are known. What is the measurement of the third angle? Yes, Maya, what did you do?
We add 22.5 and 90.
Yes, all of the angles in the triangle, the measurement of the summation of them is 180. This 180 is the summation of 22.5 plus 90 plus the measurement of angle 3. Then after you subtract them, you will find the measurement of angle 3.
Okay.
Okay, thank you. Now, in this postulate here, they told me that if two figures, oh, before that, what's the meaning of congruent? How can we say that these two shapes are congruent? By what?
By SSS or SAS or ASA
or ASA.
or
Yes.
the A.
Yes,
And we
but
have
okay,
S
so
also
what's the
right
meaning
side.
of congruent? Does it mean they have a different size or equal size, different
No,
shape
equal
or
size.
same
Equal size.
with equal
Equal
size and equal?
angles.
I mean, I have two shapes. They have the same shape
Yes.
with same size?
No, same shape with the same sizes.
Yes, that's me. That's what I mean. So the means of or the definition. Sorry. The definition. Sorry. The definition of congruent that we have the same size and the same shape. What does it mean? That's when I have two triangles, 3, 3, 3. Two triangles, 4, 4, 4, and so on. Now, this is so they are, both of them have the same shape, both of them are triangle, and both of them have the same size. In this postulate here, and I will us know that the meaning of or definition of postulate is a result of theorem. What does it mean? That's mean here, if we have two shapes have the same size, they told me that they will have the same area. Okay, if two sides are congruent, they have the same area. Okay, that's what helps with me now. In this postulate, how can I use it? As we said, that if we have this circle and we cut, or we have this center here, and we cut them. We made here a 1, 2, 3, 4 pentagon. Here now we made a pentagon. Now from this shape here, the pink one, how many triangles we have? We have 5. Is it right?
Yeah. Right.
Okay. Now all of us know that from the previous lesson that the area of any triangle is half the base
Times the height.
the base times the height. This is the area of the triangle. If we have now, we said that for the pentagon, all of the apothegm are the same. All of the bases, since it is irregular, all of the bases have the same magnitude. I mean, if this is 4, it will be 4, and this side will also be 4. So if we have this one, both of these two triangles, both of them have the same base, and both of them have the same measurement of legs. Can we say that these two triangles are congruent?
Yes.
Yes,
Yeah.
by SSS. Does it mean that all of these two triangles also are have the same area?
Yeah, they should.
Yeah, from this postulate. Okay, so what does it mean? That means if I want to find the measurement of two triangles, I will multiply the area by 2. Now, let's make it now as a polygon. We said at the beginning here that the line segment that is perpendicular from the vertex to the base, we name it with an apothegm. So instead of H, I will write A. Now, keep the base as it is, and here as a half. Then, let's name now the base with an S. Name it with S, like side, not base. Let's name it now with S. So let's make it now with S. So the area now of the triangle in here, it will be half side, this is the side, times the apotheme, which is here. I didn't make any change. This is the area for one triangle. If I have now 5 triangles, what I have to do? I will multiply the area by 5.
By 5, yeah.
So if I multiply all of them by 5, and if I multiply here also by 5, does it make any change?
No.
No. Because of that, this is for a pentagon. What about the hexagon? We multiply by 6. So half the number of the sides, multiply by the sides, multiply by an apotheme, we have to find the area of any polygon.
And can't we just say that the number of the sides
Yes,
multiplied by
the
perimeter?
Yeah, the area now. So by now we will know that the area of the polygon is half the number of the sides, multiply by the length of the sides, multiply by the length of the apotheme. Then
But this is why we didn't skip the side. Like here, the number of the sides, so it's half times 5 times f.
sorry.
Why we didn't skip the s? Like why you don't say half times 5 times f?
Yes, but skip? No, I did just I say this is for a pentagon. Just I multiply by 5, but for any number of or for any polygon, I will multiply by n. If it is pentagon, I multiply by 5. If it is hexagon, by 6. And this is a general formula, the white one. Then, and all of us know that if I want to find the parameter of any shape, like triangle or a square or pentagon or so on, and all of them have the same size, have the same length. I mean that let's clear here. If you have this triangle and this is 4, 4, 4, and I ask you now to find the parameter. What is the parameter of this triangle? What is the definition of parameter? It is the area or the length around
3 multiplied by 4.
So we will say 4 times 4 times 4 plus 4 plus 4, or you can say 4 times 3. So, and also if we have 4 as, or if you write 4 as the measurement of the side, and 3 is the number of the sides. So the general formula here is n times s is the parameter. If I'm talking about square, I will say 4 times the measurement or the length of each side. If I'm talking about pentagon, you'll say 5 times s. So that's mean here I can now rewrite this formula. Instead of writing ns, I will writing with the parameter times a multiplied by half. So the area of a polygon is half the parameter times an apotheme, half PA. How can we find P? By multiplying the number of the sides by the length of each side. This will be our theorem for this lesson here. That we said an area of a regular polygon is half the product of an apotheme and the parameter. This is the area of any polygon, half AP. Now look at this problem here. What is the area of a regular decagon? So Here we have a decagon. How many sides for the decagon? There are 10. Thank you. So, since it is a decagon, so they have 10 sides. They asked me now to find the area. We said that the area is half the apothem times the perimeter. Now I have to find from the shape here, where's the apothem? Is it 8 or 12.3? 12.3, because I'm looking
It is the
at
number of the
the sides that perpendicular on the side, which is 12.3. Now I want to find P. We say that P is the number of the sides times the length of the side. Since we have a decagon, so the number of the sides are 10.
10 times
Is
8.
it right?
Yeah.
Then, what is the length of each side here?
8.
Is 8. So, the perimeter here is 80 inch. This is for the perimeter. Then, this is an 80. I multiply 80 here. I will replace P with 80, A with 12.3, this one here, and times half. Then after that,
It will equal 492.
12.3 multiplied by 80 divide by 2, it will be 492. And as we know that the area of any, or the unit of an area is inches squared. Is it clear?